Alrighty, today I'm working on a 2016 Ford F350 Super Duty with the 6.7 diesel. Issue with this one is when you're hauling a camper, pulling a heavy load like a camper, it would throw a code, show you here, these papers straightened out. It would throw a P0402, which the definition of that is an exhaust gas recirculation, or EGR flow excessive detected. So basically it's got too much EGR flow. If it was a P0401, it'd be not enough, but it's got a 402, so it's got too much flow. What happens then, it's got too much flow, and it puts the truck in limp mode, and then you can't pull the camper. It can only go so fast and all that stuff, right? Typically, I see this when it's pulling a heavy camper or pulling a hill, you know, going up a hill or something like that. So the definition of this P0402 exhaust gas recirculation flow excessive detected is: this diagnostic trouble code sets when the pressure ratio of the manifold absolute pressure, or MAP sensor, signal and the exhaust pressure, EP sensor, signal across the EGR valve is not as expected. The estimated EGR percent is greater than the maximum limit for the operating conditions. Well, they give you a little punt list, right? But, you know, I don't really go off of those. We can check for intake leaks, restricted airflow, your charge air cooler, EGR valve position bias, your exhaust pressure bias, MAP sensor bias, and damaged EGR valve. Well, what I think's going on is, I'll show you here. Here's a wiring diagram. So this is your EGR valve here. There's your motor going to your, what's controlling it? The PCM is controlling this. Your EGR valve, you got power and ground to the motor, and then reverse the polarity for power and ground to move the motor back and forth. Well, there's a position sensor in there, so the computer knows from the signal wire going back what the position's supposed to be. Well, what's calculated all this is your exhaust pressure sensor, this one, 3-wire sensor, and your MAP sensor. On these Fords, these are MAP sensor. So on a Chevy, like a Duramax, it uses a mass airflow sensor. And if they're dirty, it'll throw the calculation off. This Ford has a mass airflow as well, but what they use on this one to calculate the EGR flow is the MAP, or manifold absolute pressure, air density. And it said that in this definition right here between the MAP and the EP. It's not agreeing, basically, right? So right now it ain't doing nothing because we're not pulling nothing or driving it up a hill. But as soon as we hook something up, it'll put it into a limp mode. So MAP sensor is typically what I've seen that causes these issues. So I got some data pulled up. I got the key on, engine off. Obviously the engine light's on right now because I got key on, engine off, which just tells me that the computer's alive. There's no codes in here right now, but intake manifold absolute pressure A is 12.92 psi, right? So we're at 3,000 feet here in Mountain Home, Idaho, and I believe the atmospheric pressure is around like 13.2 psi or something like that. But so we're close, right? And it's a 0 to 5 volts right there. So 0.96 volts equates to 12.92 pressure, manifold absolute pressure. So now I'm going to go ahead and pull the MAP sensor out and look at it, and I would suspect it's dirty, because if it's dirty, it's going to restrict that and cause issues with these readings. And we're going to pull it out, clean it, and then we're going to rerun it, check some data, and the real test will be pulling the camper, you know, pulling a heavy load like that up a hill, or pulling a camper, and then we'll go from there. So now I'm going to pull the MAP sensor out and show you guys what it looks like. Actually, let me show you these. There's no codes right now, real quick. We had a continuous memory. So they drove it down from Boise today, but of course it's pretty flat going from Boise to Mountain Home. So it didn't throw any codes, but they weren't pulling anything either. So we'll read the continuous memory diagnostic trouble codes. See if there's anything in there, which I don't expect it to be. So no fault codes. And I did all these other tests earlier, key on, engine running, key on, engine off test, all that stuff passed. So now we're going to go ahead and pull the MAP sensor and show you that. Before I pull it, I do want to show you now I got the key on, engine running. Not that that's going to change much, but it changed a little bit. Intake manifold pressure is 13 psi, right? So we're going to go from there. Now I'll shut it off and pull the sensor and take a look at it. Now this data you're looking at right now, again, is key on, engine running. We're going to go ahead and shut it off, pull the MAP sensor, take a look. But let's graph this before we do that. I know I keep changing my mind here, but I just want to get all the data I can. Of course, to see a change in there when I rev the engine up a little bit, because it's changing pressure in the manifold. So if you come up here, the map sensor, you can see it there. Get on my step stool. This is the map sensor here. 3-wire sensor going in there. We're going to pop that 7mm bolt out and take a look at it. Alrighty, so we pulled the map sensor out, but before I show you that, I did look around this. There's no intake leaks, no charger or cooler leaks, none of that stuff. There's the mass airflow. We looked at all that, filter. Everything's clean, good to go. We looked at that before. But here's the map sensor. You can see that there. I got to get the focus. You can see all that carbon on there. If you can see that in the picture or not. But look at that layer of carbon. There's the O-ring down there. Look at that carbon on top. All that carbon's on top and down inside the map sensor. So of course that's going to change your map sensor readings. You may not notice it a lot at idle, but if we were to graph it going down the highway before and after cleaning it or getting a new one, you would definitely tell the difference. I believe this is causing a problem because this is one of the primary inputs. So we're going to try to clean this the best we can. Again, it's not like a mass airflow where you're cleaning a hot wire resistor, so we'll do the best we can and go from there. And if not, it's going to have to eventually get a new map sensor put in. And I would recommend getting a good name brand one, get a Ford one. I wouldn't not get a Duralast one or aftermarket one like that, because those parts are garbage. So we're going to go ahead and... So I took and cleaned it. It's a lot better. You can see the top there. Inside, I got a lot of that carbon out. There was a ton of that carbon, that black soot built up in there. Hopefully it's good enough. If not, it's gonna have to eventually get a new one, but now we got to put it back in and do the actual test. But it's 100 times better than it was. So if you look, we got the sensor back in, plugged back, or bolted in, plugged back in. Go over here. Right, if you look up here, both the same pressures. Change it a little bit. We're going to go ahead and start it. Now it's running. Both the same, but the real test, like I said, is when you actually drive it and put it under a load condition, because that's what will really change it. We can rev it up. I don't think we're going to see much difference until we actually drive the vehicle. So what we do from here is hook the camper back up, drive it, go from there, make sure there's no faults, make sure it doesn't have excessive flow. If it continues to do so, obviously I didn't get all the carbon out of there, I would have to get a new manifold absolute pressure sensor, and that would fix this truck. So that is it for this vehicle.